In section 4.2 in our book, we're going to talk about the addition rules for probability. When we are looking at an event, maybe a compound event or more than one possible thing happening, then we have to adjust our probability rules from the last section. Okay, so when we start, we have to understand the idea of whether or not two events are mutually exclusive. Okay, two events are mutually exclusive if they cannot both happen at the same time. Okay, I'm going to write no overlap there. Okay, if they can't happen at the same time, then they're mutually exclusive. So, for example, if I am a freshman and somebody else is a sophomore, those events are mutually exclusive. A student is either a freshman or a sophomore, but they can't be both at the same time. Maybe I'm looking at the events being a freshman and being a female. Those events are not mutually exclusive because we do have students on our campus that are both freshmen and female at the same time. Okay. So mutual exclusivity means there's no overlap. It's not possible to be both at the same time. All right, so maybe I am back to my deck of cards. And I'm going to draw a single card from that deck. I want to know the probability that that card is a heart or a spade. So the probability that I draw a heart, maybe I can draw a heart like this. We know that there are 13 hearts out of the 52 in our deck. And the probability that I draw a spade, I'm not going to try that on this guy here. Also 13 spades out of 52. So the probability that I would draw a heart or a spade means there are 26 cards total out of the 52 that would make this experiment or this event a success, okay, or half the time. Okay. If we think about the events drawing a heart and drawing a spade, those two events are mutually exclusive because a card, it can be one or the other, but it cannot be both a heart and a spade at the same time. But if I say I want to find the probability that I draw a heart or I draw a 3, if I just add together those two probabilities, there are 13 hearts and there are 4 3s, and I just add those two events together, what have I done? Since these two events are not mutually exclusive, there is a card that is both a 3 and a heart. Okay, these guys are not mutually exclusive, which means if I just add those two probabilities together, I've added some of it in there twice. So if I think about how many cards are both hearts and 3s, there's one of them from the deck. So there's one of them in there that I counted twice. And so that leaves me with 16 out of 52. And we can reduce to say 4 over 13 for that probability. If I want to find the probability of two events, one or the other happening, probability of A or B, I start out by adding those two probabilities together. The probability that A happens and the probability that B happens. But then I have to subtract out anything that I've counted twice. So I have to subtract out the probability that both A and B happen. If we come back up here to our heart or spade example, we say, well, there are 0 cards that are both hearts and spades. So there was no overlap there. that probability would be 0, the probability of A and B. But when we look down here with the heart or the 3, then there was some overlap. Okay, there was one card that is both a heart and a 3. So let's think about the probability of drawing a jack or a king. Maybe I want the probability of drawing a queen or a spade. The probability that I draw a red card or an ace. Probability that I draw a black card or a heart. So pause the video on this, see if you can use the formula the right way, and when you turn it back on, the answers are going to be here, so don't turn it back on until you're ready to see the end. Okay, the probability that I would draw a jack or a king, there are 4 jacks in the deck, and there are 4 kings in the deck, and there is no overlap at all. There are no cards in the deck that are both jacks and kings. You don't have to write the -0 on your paper, but I'm going to write it to show that I considered that option. So there's 8 cards out of 52, which reduces to lowest terms as 2/13. Queen or a spade, there are 4 queens, there are 13 spades. There is 1 card that is both a queen and a spade, and so I have to subtract it out, and I get the 4/13 just like we did up here. I want the probability that the card is a red card or an ace. There are 26 red cards. There are 4 aces. There are 2 red aces in the deck, leaving 28 out of 52 cards. And the last one, there are 26 black cards. There are 13 hearts. There are no black hearts, so I have nothing, no overlap. These are mutually exclusive events. So I subtract out nothing and get 39/52. Okay, we'll do some more examples in the next video.